So instead of lower 10% like we did in part A, they're looking for the upper 5%. We could find that, right? If we want to know what is the x up here that defines the upper 5%, well, we know it's going to be above 7,000 because 7,000, 19% of the families spend at least that much. We've got to go quite a bit higher to get to where we're down to the upper 5%, or the 95th percentile, however you want to think of that. Okay, well, again, it's the case that we need to translate that into its corresponding z statistic, the z that has 0.05 in its upper tail. Now, you could look up 0.95 in your table. Okay, again, in the body of the table, if you look up 0.95, we can get pretty close, but we're kind of split right down the middle because we've got 0.9505 and 0.9495 seem to be equally far away from what we're really looking for, 0.95. Let's think about that table that we saw in Chapter 8 when we were talking about z statistics and their tail areas. What was the z statistic corresponded to a 5% tail? It was 1.645, right? Okay, so what this is saying is that this z is 1.645, and we can go back to a notion, this notion here, and just plug in 1.645 now instead of negative 1.28 to get the upper 5%. Okay. Now, if you use 1.64, if you use 1.65, that's accurate enough. That's really getting us. You're doing the right thing with that problem. If you wanted to, use the information we learned a couple chapters later, and recall that 1.645 corresponds to a 5% tail, which we've seen in a lot of other things we've done in chapters 8 and 9. If that's the case, then we can just plug in to find the x critical in part C. X critical would be equal to 5,700 plus 1,500 times 1.645. Kind of write these things together. Okay, this would be for part C of the problem. And when you do that multiplication, I believe you're going to end up with around 8167.50. Which I think makes sense in light of our graph and our understanding that we knew this had to be above 7,000.
And this is a formula, this is a normal distribution formula.
Yeah. The reason that of these three formulas, well, okay, we've done chapters 6 through 9 to this point, and I'm not sure which of those chapters will be on your exam and which won't. I'm not sure about chapter 9 yet, or your quiz. Quiz is supposed to be kind of smaller than an exam, and I don't want to put everything we've done on the exam size, and we're taking up a lot of class time, and you get all the stress and everything. So I probably won't put chapter 9 on. I'm kind of leaning away from chapter 9 at this point. If in a couple hours this evening we cover chapters 6, 7, and 8 very thoroughly, that might be a sign to me that 9 needs to be moved to the final exam. But we know that this isn't a hypothesis test because we weren't asked for any testing, so it's not chapter 9. We weren't asked for a confidence interval or margin of error or anything like that, so it can't be chapter 8. That's why we know it's down to 6 or 7, and they didn't give us a sample mean or a sample proportion in the information provided, so we know that it can't be either of these formulas. Based on what we know, what they've given us, we can assume that we're going to be working with this distribution, or this formula that relates just a general normal distribution, which they've said this is. They said that assume the annual expenditure on food and drink is normally distributed and has a standard deviation of, okay, so they gave us that. By process of elimination, we know that we have to use that first formula that we've discussed. Okay? And that was the very first thing we talked about once we got into notes 3 weeks ago.